Advanced technology and precision craftsmanship. A main battle tank with incomparable crew protection. Quickness and agility. Firepower.
In the early 1980s, the M1 Abrams was about to get its first major upgrade. The Abrams was the backbone of the US Army's armoured forces, and was one of NATO's most important assets in defending Western Europe. The upgraded vehicle, designated M1A1, would feature a redesigned turret with a new 120mm smoothbore gun, as well as multiple enhancements that would improve crew survivability. Behind the scenes, however, American engineers from the US Army Tank Automotive Command, or TACOM, were working on an unconventional new design that they hoped, if successful, would end up entering service as the M1A3. The premise was pretty simple. You don't need to add heavy armour to the turret if there's nobody inside. The aim of the project was to redesign the Abrams tank to incorporate a completely unmanned turret. This turret would hold a 120mm main gun and its accompanying autoloader, but not much else. This meant that the vehicle could be reduced to a 3-man crew, as the loader simply wasn't needed anymore. The gunner and the commander could operate the turret remotely, and sit with the driver in a heavily armoured crew compartment that was entirely separate from the gun, and, more importantly, the ammunition. This arrangement hugely increased the survivability of the vehicle, with a thick layer of armour separating the crew from anything that might explode if the tank was hit. Another benefit of the design was that the turret was significantly smaller than that of the Abrams, meaning it was more difficult to see and to shoot at. A smaller turret also meant less area to armour, and less armour was needed anyway since there was no squishy crewman to protect inside the turret. Development work soon began on the new hull, turret and autoloader that were required for the design. The first iteration of the hull was finished first, with construction being completed in the summer of 1983. This vehicle was referred to as the Surrogate Research Vehicle, and was designed for the sole purpose of testing the new hull layout while the turret was still in development. The SRV kept roughly the same hull arrangement as the M1. The power pack was in the rear of the vehicle, the turret was in the centre, and the driver sat at the front. However, the driver was no longer alone. The gunner and the commander, evicted from the turret, were moved to seats either side of the driver in an armoured capsule at the front of the vehicle, each with their own viewing periscopes, as you can see here. The gunner sat on the left of the driver and the commander on the right, and in front of them was a spaceship-esque unified control panel that operated the entirety of the vehicle remotely. In a standard M1 Abrams, the driver sits in a reclined position, allowing the hull to be as low profile as possible. In the SRV, however, the hull roof has been raised by a few inches, so it almost sits level with the engine deck. This change was made to eliminate the need for reclined seating, as the gunner and commander would need to be upright to properly utilise their various sights and equipment. As well as raising the roof, the SRV was a lot longer than a standard Abrams, thanks to all the extra equipment that needed squeezed into the crew compartment. To test this unique crew arrangement in actual combat scenarios, the designers needed a way to simulate the turret and the gun. As a result, on top of the SRV, there was a tall tower covered in an array of camera equipment that could rotate just like the turret. The crew would be able to see the outside world through these cameras and rotate the simulated turret from their protected compartment, making it possible to test the design despite not actually having a turret to hand. Additionally, some reports suggest that the SRV was later equipped with a laser system, allowing simulated aiming and firing of the main gun. The next prototype to be built wouldn't need a laser system because the new autoloader was finally ready. In early 1983, TACOM had awarded the contract for the design and manufacture of the new autoloader to the defence contractor Meggitt, who had previously worked on the autocannon loading mechanisms of the Cobra and Apache attack helicopters. The new system stored the 120mm shells in a 44-round capacity ammunition carousel located in the unmanned turret basket. The transfer unit located behind the breech of the gun would flip forward and extend down into the basket, grabbing the base of the desired round. It would then pull the round upward and flip back down, laying the round horizontally on the transfer case. Then the rammer would slot the round into the breech and the breech would close automatically. All of this was completed in a matter of seconds, and allowed the 120mm M256 cannon to fire at up to 12 rounds a minute. The spent round was then ejected out of a port on the rear of the turret, which could also be used by the crew to unload or load rounds into the carousel for replenishment. The Megget autoloader was rigorously tested before being added onto the vehicle, with the test regime including a requirement for the system to load a round from the storage rack, unload the same round back into the rack, and repeat for the adjacent round. This process was repeated until each round had been loaded and unloaded 20 times, all without making any marks on the combustible outer case of the shell. It's relatively easy for an autoloader to load shells on a stationary vehicle. What's not so easy is doing it on a moving one, especially if the vehicle was moving cross-country. In order to properly test the autoloader under these conditions, TACOM designed their own vehicle motion simulator, which would shake and shimmy just like the real thing. Even under these conditions, the Megget autoloader was able to fully cycle 40,000 rounds before one failure, enough for the vehicle to fire its entire ammunition load nearly 1,000 times. It was safe to say that the autoloader worked, and it was ready to be paired with the hull. The new vehicle was referred to as the M1 Tank Testbed, or TTB. This design featured a slightly revised SRV hull, paired with the 120mm gun and the autoloader, mounted in the new low-profile turret. The turret was made just large enough to fully enclose the autoloader and gun equipment, and mounted some external camera equipment for the crew to use. Additional TV cameras were conspicuously mounted on either side of the front of the vehicle, in an attempt to enhance the visibility of the three crew members. Now that the TTB was a complete vehicle, it could be properly put through its paces. The extensive test program was reported to last up to the end of the decade, and showed that the vehicle had huge advantages over the standard M1. But the geopolitical landscape was changing.
From ABC, this is World News Tonight with Peter Jennings, reporting tonight from Berlin.
With the collapse of the USSR almost inevitable as early as 1988, the main armoured threat to NATO was greatly diminished, and there was simply no need for a pricey overhaul of the M1. The TTB's complex control systems were hugely expensive and relatively unreliable when compared to the simple manned turret that it was designed to replace, with significant maintenance required to keep the vehicle operational. The sheer amount of data that needed transferred from the cameras to the crew, and from the crew to the turret and back again, was immense for 1980s technology, especially trying to transfer this data out of a sealed armoured capsule into a different sealed armoured capsule. All of this to provide less situational awareness than a commander would have been able to achieve using his Mark I eyeball out of his turret hatch. Another issue that wasn't really a fault of the TTB specifically was that the army wasn't ready to give up a crew member. The loader, when not loading the gun, is helping maintain the tank and frequently assists the driver in maintenance tasks. On a tank like the M1 or the TTB, maintenance is a huge time sink, and having an extra man lowers the workload for the crew significantly. So, for a few different reasons, the TTB project was shelved indefinitely, sometime in the late 1980s. The single example of the TTB was, as always, left to rot outside for the best part of 40 years, before being restored by the US Army Armour and Cavalry Collection, and put on display inside Fort Benning in Georgia. One of my favourite YouTube channels, The Chieftain, recently put out a great video walk-around of the TTB, which is linked up here if you want to check it out. Many of you tank buffs watching this probably noticed that the brand new Russian MBT, the T-14 Armata, uses almost exactly the same configuration as the TTB did, just 30 years later. We don't know much about T-14, but the fact that the production run of the vehicle was reduced from 2,300 to a mere 130 signifies that the problems that cancelled the TTB haven't been entirely solved, although 130 is still a lot more than one. Regardless, the TTB taught the US Army a lot, and thus served its purpose despite never being adopted or mass-produced. Maybe the Abrams replacement will incorporate some of the better aspects of TTB. Who knows? As always, thanks for watching. I'll see you next time.